What up, boys and girls, ladies and gentlemen? Jesse Warden here. Today we're going to talk about mutation testing.
Jesse Warden.
Why you should care about mutation testing, what it is, and some examples and how to get set up. When we talk about why care, the first is test quality. We have the tools in place for code quality in a lot of our CI/CD, continuous integration, continuous delivery pipelines, where we know the code is linted, we know it compiles, we know it unit tests, we know it's performance tests. We have all kinds of other testing around it and formatting and prettier, but there isn't so much on test quality. There's a lot for code quality. So this is a nice way to make sure that your tests are of high quality. And the reason that has gotten a lot more popular than it was about 4 years ago, LLMs, at least in some people's workflows, are writing the unit test. If you're one of those people who has the AI generate all the code, how do you know it's any good? And then continuous delivery. Like if we want to release, we don't want to be afraid. So let's not be afraid. So mutation testing is just yet one of many tools that make sure that you, what we call shift left, you basically run as many code quality checks locally as quickly as possible to determine, is this code worthy for prod? So let's not be afraid. So that's why you should care. Okay, so now that you know why you should care, let's talk about what it is. So it basically introduces changes into your code, then runs your unit test. So when we say introduce changes, it actually mutates your code. And so that's why it's called mutation testing. So it changes your code to see, do your test break? If your tests don't fail, it may indicate they don't cover your code enough, or they don't cover edge cases, or they don't cover the core stuff, or your types are a little too loose. They're really just types for spelling, or did I get a string or a number, right? They're not constraining or narrowing what you do, so you have to compensate with unit tests. So types play into this too. It's not just unit tests. There's a lot of ways to fix these things without just making better tests. So that's what it is. And the surprising thing to people, and I mean, this is on, I found this at work. I found this at on personal projects. And if you look in the Striker documentation website, they have an example where they have about 100% unit test coverage and their mutation score is 60. So you can have unit tests that are 100% coverage. Every possible path of this code is handled, happy and unhappy path. And then certain changes can make, flipping an if else or returning a false instead of true. And then suddenly your unit test, no, it's good. The code's good. It's like, let me get this straight. I broke the code intentionally and the unit test didn't fail. That's concerning. You want your test to pass. So false positives are really bad. So something to be aware of. Test coverage is not going to save you. Okay, so that's what your mutation is. So I want to be clear. You're not writing mutation tests. You don't write mutation tests. What you do is you improve your existing unit test through mutation testing. Now, we're talking strictly here unit testing, but you can also use types to help this too. So it's not just improving your unit test. Sometimes you can, the whole point is to run the mutation test, find the mutants, the unit tests that don't fail, the changes that it could make that cause your test not to fail, and go, how could I solve this with another test, modify an existing test, or maybe creating a type? That's what you're trying to do and iterate through that. So you're not solving all your unit tests at once or solving all problems. Sometimes the mutants are like, it's no big deal, right? It's a stupid edge case no one cares about. So that's the point. You are using mutation testing to improve the quality of your existing unit tests, okay? So here's how it works. Step one, the mutation testing, when you run it, it's going to find the return statement in your code. So in this case, we have you're building software for people to get into a club, and you're trying to see if the user's old enough. So they got to be at least 18. And so you're saying, all right, as long as their age is 18 or above, they're legit. So it's going to find that return statement, and it's going to generate mutations on changing that return value. So changing it to false, changing it to true, changing it to use a different operator, in this case, greater than instead of greater than or equal. So only 19 or 20-year-olds are allowed in the club, not 18. Like, does a unit test catch that kind of stuff? So it's going to create a bunch of these mutations and then run through each one. It's going to run your unit test with just that change. So you can see it's going to run a ton of your unit test over and over and over and over. And it's trying to find one of these mutants that'll make sure that your unit tests fail. And if they don't, it's going to let you know. So that's what they talk about, surviving mutants. So here's a report. And I get it's a bit overwhelming. So let's just focus on the mutant that it built. It changed your code or mutated your code from greater than 18 to greater than 18. So not greater than or equal than. And we already had 2 tests. We already had 2 unit tests of your birthday returns true for 19. That means you're allowed in the club. And if it returns false for 4. So if you're 4 years old, you're not allowed in the club. So both those tests pass despite now changing it to you have to be over the age of 18, not 18 or above. So the unit tests are like, oh yeah, the code change is fine. Maybe, but it's not covering that edge case, right? Now, this one is really, really simple. However, thinking about how would I cover all these cases without adding more unit tests or writing better tests? The whole point is to get you in that mode of what you're thinking right now, right? It's not to like solve every possible use case. It's just to verify, is this a concern? Now, this is one line of code. Think about when you have a large function or class method that has multiple if statements, or that is connected to this, which is connected to this, and you just change one little thing. Did you break everything? Who knows? The tests say it's green, so I guess we're good, right? So this is where the mutation test can make you think, go, wait a minute. Like I should be able to delete stuff and feel confident about my test. So this helps remove that fear and build your confidence, right? So this is a small one, okay? So that's step 3. So you can see that mutant survived. That when they say mutant survived, they mutated or changed your code, and the test passed, said everything was good, but probably shouldn't have been. And again, this is a probably. You need to figure it out. Just because it's 80% doesn't mean it's bad. Some of these are edge cases, some of these are invalid, some of these are extremely bad. So you need to figure that out. What we're trying to do now that we have a report is how do we kill what they call surviving mutants. So you have 80%, you have mutants that are leftover mutations in your code that your unit test just didn't catch. What do we do? How do we improve our unit test? Part 1 of what we had was that it changed it to greater than instead of greater than or equal to. And these are the existing unit tests we had, that if you're 19, you're allowed in the club. If you're 4 years old, you're not allowed in the club, right? It's the unhappy path. And so what we're thinking about is, all right, how can we just do brute force? Like, let's just see if we can learn how to fix this, get rid of this mutant, right? So you take in inputs of 18, 19, and 20, and then you say, all right, for every one of these, they should be allowed in the club. And so you're brute forcing it all the way up to handle the edge cases of greater than or equal, right? And you can see if you rerun it again, your mutation testing again, there's no surviving mutants. And the 5 mutations that it found for that line of code, they all failed the test. So your unit tests for this are really, really good. So again, we can still look at that unit test and improve it later, right? You can change the test pass, then rerun your mutation testing and see, all right, did my change in tests have any surviving mutants? I changed my code. Did my test break? No, I'm good. I changed my test. Is there any surviving mutants? No. Okay, we're good. Right? So you always have like a baseline you start from. So that's how you kill a mutant, and you're good. There's none left. Well done. Congratulations. Here's an example that Stryker actually gives you, for example, where they have 100% coverage on the order service and the ride service. It's an Angular application. And I chose the services in particular because those are some of the easiest thing to unit test. They have no UI components. They have no weird state. They have no observables, no signal. It's literally just pure functions with like 1 or 2 dependencies that you usually can stub or you mock if you don't want to do a stub. 100%, right? Should be good. But if you run the mutation test against them, they're really bad, right? It's 58% for the order service and 71% for the ride. So they're not covering some unhappy paths. They're not covering edge cases. And your goal, if you want to play with that code base, you can go download it from Stryker, is to kill those mutants. So that gives you a good practice run on some other code base that already has 100% coverage. And the reason that's interesting is that it gives you, because of 100% coverage, a variety of tests to choose from and say, which one would I use to kill the mutants it found, or would I write a new one, right? It's just kind of a fun way to play. How can mutation testing help? It gives you a new measure to help you identify if your tests are any good. So we have a lot of code quality measures like unit test and linting and compilation, cyclomatic complexity, like all kinds of things for code quality. But you usually don't apply those to unit tests, right? Again, we also now know we have some way to automate, are our AI unit tests any good? It's just another way to say, all right, AI is generating more and more of the code. What can we do to validate more and more of the code is higher quality? This is just yet another tool to help with it. When these mutation tests improve our tests, we just get that much more confidence that we can go to prod. Mutation testing is one way to help to make you feel better, to go, my tests really are good. I feel great. Let's go to prod. Like that's a really good feeling. If you want to do it, there's 2 ways you can do it. The first is if you're a JavaScript dev or TypeScript dev, You do an npm init, and it'll walk you through the steps of if it's front end, if it's back end, and what my configuration file looks like and how do you set it up. Then you just do npm striker run. The other way, if you're Gen Z or just tired, you can prompt it. I've done this on multiple projects where I'm like, I want to get 4 repos in a row. So I say, just add mutation testing with Striker in this repo, and then I just go do something else. If you want to learn more, be aware that as you start running these things, mutation testing can be really, really slow. I mean, it depends on how your CI/CD process, what your environments are, but I highly recommend as a default, you treat them like performance tests. So some repos take 5 minutes, some take 12 hours. No joke. It's very similar to the beginning of the project where you kind of get like some baseline, and then you kind of run it against either a mutation coverage score, right? Like what's your score? And so as long as you don't go below it, you're not making the code worse. Or you run it against the diff. So for example, if you are checking in 2 new files, just run the mutation testing against what those files would affect from a unit testing perspective. So if they're isolated modules, great. If those modules affect other things, maybe run against the modules they touch. And so that way the mutation tests are a lot more focused and they don't have to take hours and hours and hours. There are ways of running it with Husky and pre-commit scripts where it can do the change too. So it'll just do the git based on diff of what you checked in. So that way you don't have to wait 5 minutes to do a commit, right? It only take like a few seconds. Types can solve a lot of this, especially with discriminated unions and records. Yeah, the opposite angle. Property tests can help too, because property tests are the opposite of mutation, kind of. You go to Striker Mutator.io. They've got examples for JavaScript, but I mean, you can use it for Go. Like I think it's Go, Scala, and C#, I think. So yeah, you can learn more there. But just be aware, it's a guideline. You're just trying to identify what tests you think really should be testing as edge cases. The other ones, if you know they're like configuration or routes or top level stuff that never changes, that's fine. The goal is not to get 100% coverage. The goal is just to make you think, was I aware of that edge case? Or is the test that the AI is generating, does it have any kind of quality checks on, what's writing if we're not doing human review? Right. That's mutation testing. I'm Jesse Warden. You got any questions? Let me know in the comments. I'm here to help. Good luck destroying the mutants.